A very good morning, class. So here we are with the coordination chemistry lecture number 2, and in the previous lecture we have learned about that what is the coordination bond and what is the coordination chemistry, and denticity and the ligands we have done. So in continuation of that important terms, we are going to learn about more terms over here. So let's start the video. First one, we are going to learn about the coordination polyhedron, which is also known as coordination sphere. Yes, so this is in general words, it is said as sphere, but in bookish language or might be in some other books, you can see that polyhedron. So I have mentioned over here polyhedron. So the special arrangement of ligands around the central atom, central metal or ion is called coordination polyhedron. So this is called, I have already told you that what is this. This is the coordination polyhedron. That means it can be like hedra. That means it can be seesaw, it can be trigonal bipyramidal, it can be square pyramidal, tetrahedral, it can be octahedral. So out of this, lots of there, 2, 3, 5 and 9, 12 hedron are there. But out of that you have to learn the most important is octahedron, the square, the trigonal bipyramidal, somewhat you can see, tetrahedron will be an square pyramidal, and the seesaw very few. Okay, so these are the 5 hedron are important and that will be used. Rest all are not so in use in our board syllabus. Okay, so now the next term is oxidation number. What about this polyhedron and how to draw the structure and all that, that we will also do in the geometry. When we will do the geometry, there we will do. Okay, so now the third topic is that oxidation number. And about the oxidation number, we know that we have done in class 11, so we have little bit idea about that. The oxidation number of the central metal atom or the ion is in a complex is the charge present on it if all the ligands are removed along the electrons pair and that are shared with the central atom. सारे जितने भी ligands हैं अगर उनको remove कर दिया जाए उनके electron pair के साथ, so whatever the charge is present on the metal atom, that will be considered as the oxidation number. So never it will be asked that what is the definition, it will never be asked, just to know. Okay, now it is represented by Roman numeral. It is important thing over here in the coordination chemistry, the oxidation number should be mentioned in Roman numerals in the parentheses just after the name of the central atom. The metal we will write, and after that we have to write the oxidation number, and that should be in the Roman, yes, numerals. For example, oxidation number of cobalt, iron or Ni in these 3 different compounds, cobalt in this, Fe is in this, and Ni in this is +3, +2 and 0. How it is we will do, don't worry about that. फिलहाल इतना ये देखते हैं, ठीक है. So that will be written as cobalt की बगल में 3, Roman में Fe 2, Ni 0 respectively. Did you get that? How to find the oxidation number as we were doing in the in our class 11th we have done. So in the same way we will do. Okay, so before that let me show you one by one slide that how to find the oxidation number. So now let's do some example like how to find the oxidation number of the given compound, given like a metal in the given compound. Okay, so here I have written few examples like K4FeCN6, and here's the central atom. We have to find the oxidation number we have to find for the central atom. So central atom, that means which is in the big parentheses, isn't it? So here we know that potassium is always having +1 oxidation number. So how many potassium are there? There are the 4. So that is 4 into +1. And this is the central atom. So let's assume that its oxidation number is X. So it will be like this. And Cn is in -1 state. So 6 into -1. As we have done in class 11th oxidation reduction chapter. So the same way we have to do. The one thing you have to learn here, that is the charge of each ligand. That you have to learn, that which are the neutral ligand, which are the positive ligand, which are the negative ligand, that you have to learn, and what charge it carries. Okay, so that it is must. So Cn is -1, so that's why if you solve it you will get that X is equal to +2. Similarly in this compound, this is the neutral ligand, so this is 0. So 0 into 4 it becomes 0, and this is -2, so obviously the copper must have +2. In this case, this NO you have done in the nitrous neutral ligand also, that is nitrosyl. But in this case, this is the brown ring complex, and here the NO is having +1 charge. It's not a neutral ligand, it's a positive ligand. So positive ligand, it is nitrosonium. Okay, so that's why this is 0, but this one is +1, and if we solve that, we will get +1 oxidation number of iron. So I hope it is clear. So now the next slide is about the homoleptic and heteroleptic complexes. Homoleptic and heteroleptic complexes, what are there? If the ligands, it is depending upon the ligands. If the ligands are only of one type, whatever the number of ligands are there, but if it is of only one type, then it is called homoleptic. And if it is like different types are there, more than one types are there, then it will be called heteroleptic. So let's do some example also. Like this is, we can see that only 6 ligands are there, but all the 6 ligands are of same type, amine. So that's why it is a homoleptic compound. And here in this case, you can see that ligands are amine and the chlorine. 2 types of ligands are there, so that's why it is called heteroleptic. I hope it is clear. This is like important point according to entrance point of view, not like been asked in your board exam. I wanted to make a star, but ये कुछ और बन गया. Let it be. Okay, so this is flexidentate ligands. Flexidentate ligands का मतलब होता है like which can show different charges. Like when I have told you about that EDTA I have told that it has -4 charge. So EDTA की density जो होती है that is 6 we have done. Yes, it has 4 oxygen ligand, 4 oxygen atom and 2 nitrogen. So accordingly it is 6. But if its density is changing depending upon the metal, then it is called flexidentate ligand. So EDTA can show the density 4 as well as 6 depending upon the metal ion. So that's why it comes under flexidentate ligands. Now, what is chelating ligands? In the previous video, I have so many times I have used this word chelating as in chelating ligand and chelation, what it is. Chelating ligands are those ligands which are capable of making a ring-like structure. That means except monodentate, all will be considered as the chelating ligands because at least 4-5 members ring they make. Yes, so ligands resulting in closed ring structure with the metal ions are called chelating ligands. And chelating ligands जो होते हैं, they are the stable. In comparison to monodentate, they are stable. जितने ज़्यादा membered ring होंगे, उतने ज़्यादा वो stable होंगे. Got it? So ethane 1,2-diamine is involved in formation of cyclic ring with copper 2 ion. There's an example. Okay. Like we can see that here, this is the ethene diamine, CH2NH2, ethene diamine. Here also it is. So in this, copper is forming a ring-like structure. In this, it is like 1, 2, 3, 4, 5 membered ring is there. So this gives the stability to that. So this is called chelating ligands. All that bidentate, tridentate, tetradentate and hexadentate, they are called chelating ligands. More number of members in the ring, more will be the stability. Now, nomenclature of the coordination compound. How to name the coordination compound or that complexes. So there is some rule that, and that rule, if you want to learn, it won't be like, it will not retain in your mind. So the only way is to practice. As much as you will practice, you will get the things. For the references I have written over here. So just go through with this one by one. फटाफट कर लेते हैं. It is very convenient to get information about constitution of compound if we know the formula. Mononuclear entities contain a single central atom. ठीक है. To write the formula, following rules are applied. The central atom is listed first. Central atom को हमें decide करना होता है because oxidation number we have to find for that only. Ligands are then listed in alphabetical order and then their placement does not depend on their charge. Unki jo, this is the way, this is the method, this is the rule to write the formula. That means हम कभी भी coordination sphere in the complex we are doing, it always starts with the metal. Coordination sphere के अंदर पहला जो element hoga या compound hoga, whatever, that will be the metal central atom, and then after the ligands will be there, and ligands will be in alphabetical order. it is irrespective of their charge. Whatever the charge it is having, whether it is monodentate, didentate, or like bidentate, or it is one charge, it is having -1, -2, or 0 or plus, whatever, irrespective of that, alphabetical order में we will arrange. Yes, alphabetical order कहने का मतलब according to the name. जैसे if we say that CN is there and NH3 is there, so NH3 is amine and CN is cyano, so amine will come first and cyano will go afterwards. Yes. In case of abbreviated ligands like polydentate जो भी होते हैं, like glycinato we can say, like EDTA we can say, ethylene diamine we can say. So for that we need abbreviation. We write abbreviation. The first letter of the abbreviation is used to determine the position of the ligand in the alphabetical order. Okay, like for the pyridine we use PY, for glycinate we use GLY, for oxalato we write OX. So the first letter will decide the alphabetical position. Yes. Now the next thing, other rules. Entire coordination entity is enclosed in the square bracket, whether the charge is there or not. Charge agar hoga, we will mark the charge over there, and if charge is not there, it will be like that only. Polyatomic ligands are enclosed in parentheses. If it is ligand like didentate, tridentate, so we are supposed to write that ligand also in the small bracket. Okay. So, and also their abbreviation also we will write in the small bracket. Like if it is Cl, monodentate, unidentate, we can write simply without any parentheses. But if it is bidentate, tridentate, like En is there, like GLY is there, PY is there, it should be written in the bracket. Yes. There should be no space no spaces left in between the names of the ligand and the central atom. हम कोई भी उसके formula जो भी whatever abbreviation and central atom whatever we are writing, there should be no space in between that. When the formula of a charged coordination entity is to be written without counter ion, the charge is indicated outside the square bracket as a right superscript with the number before sign. That is, I think, it's a छोटी सी बात है, बच्चे वाली बात है. So it is clear, whenever it is counter ion नहीं है, तो whatever the charge is there, that charge must be written over like as a superscript outside the square bracket. Yes. And first number and then sign. Now next is example, like we can see that COCN6 3 minus CH3 plus, like this. So we are supposed to write the charge. If counter ion is not there, we are supposed to write the charge after the square bracket. In this case, cation is not there. In this case, anion is not there. Any counter ion is not there. So we will write the charge. Charge on cation on anion is counterbalanced. हमेशा वो balanced होते हैं. Whatever the charge, positive and negative, will be equal, then only the compound will be neutral, isn't it? Now the next thing, writing the formula of mononuclear coordination compound. Mononuclear, like which is having only one atom. So by applying the principle of additive nomenclature, the groups that surround identified and they are listed as prefix to name the central atom. I will give you a small formula for that. It is the rule. Just go through with that. Following rules are applied for naming of the coordination compound. Now, how to write the name of the organic compound, coordination compound? Yes. So for this, the positive part of the complex compound will be named first. Either it is simple or it is complex. The positive part will be written first, followed by the negative part. Yes. Ligands are named first in alphabetical order, followed by central atom. Reverse in case of writing formula. जैसे फॉर्मूला में हम पहले सेंट्रल एटम लिखते थे एंड देन सारे लिगेंड्स, बट इन दिस केस पहले सारे लिगेंड्स एंड देन एट लास्ट वी विल राइट द सेंट्रल एटम. Prefixes like mono, di, tri, tetra are used to indicate the number of ligands. If it is monodentate, so we use mono, di, tri. If one is there, so no need to mention. If two is there, di, three is there, tri, like this. But if it is complex ligand like En, bidentate or tridentate or hexadentate, if they are, so then instead of di, tri, tetra, we use bis, tris, tetrakis, like this. Got it? So ये prefix use करते हैं हम. Rules for writing formula of mononuclear. In addition of that, another rules are there. For example, like this NiH2O whole twice, En whole twice, SO4 is named. So this is 2. H2O is mono unidentate, so we will write di-aqua. Yes, and this one is we say complex. So it for this 2 is also there, but we will not write di, we will write bis. Bis ethane 1,2-diamine or ethane diamine. Yes, nickel, and the oxidation number is 2, sulfate. How to find the oxidation number? I have told you that Ni is, suppose it is X, and H2O is 0. So En is also 0, it doesn't have any charge, and this is having SO4 is having -2. So what should be charge on X? It should be +2. So that's why got it in the Roman. And then whatever the counter ion is there, as it is we will write. If this is inside the ring, अगर ये ring के अंदर coordination sphere के अंदर होता तो it should be name, it should be end with the ato, sulfato. But if it is as a counter ion, exactly same we will write. Like if it is sulfate, we will write sulfate. If it is chloride, we will write chloride. No need to change that. Yes. Chaliye, now next, name of anionic ligand end with O. Cationic ligands, as I told you, O, ato, ido, ito. Yes. And cationic ligands end with em. For the neutral ligand, regular name are used except वाटर के लिए हम एक्वा यूज करते हैं और एमीन के लिए NH3 के लिए जो कि अमोनिया होता है वी यूज एमीन, AMMINE. ठीक है. फॉर NO इट इज नाइट्रोसिल, फॉर CO इट इज कार्बोनिल, एंड these आर प्लेस्ड विद इन द ब्रैकेट. ये हम ब्रैकेट के अंदर लिखते हैं. Oxidation state of central atom ion is indicated in Roman numerals in bracket after the name of the central atom of the name of the metal that I have already told you. When coordination entity has negative charge, then name of the central atom ends with 8, otherwise not. How it is? Just wait for that. I will give you the simple formula for that. So now the format is there. How to name a cationic complex? There is a format for that. First, we will write the number of ligands, jitne bhi hain, di, tri, tetra, whatever it is. Then we will write the name of ligands in alphabetical order. Okay. Then we will write the metal and the oxidation number in Roman, and then we will leave the gap. Yahan tak it should be one word. It should be one word. There should be no gap. Got it? The first gap will be here, and then the counter ion. As for example, if it is like this, so what we are supposed to write, number of ligands first. That means number of ligand is 4 over here, isn't it? So it should be tetra. And this is homoleptic compound. That means only one type of ligand is there. So, okay, with this one, we will start 4 tetra. And NH3 is, what is the name? Amine. So tetra amine. And then we are supposed to write the metal. Metal is copper. And then the oxidation number. Find the oxidation number. It is -2. It is 0. So total is copper is 2. So copper should be in the Roman 2. And then gap. And then counter ion will be SO4 sulfate. So this is the name tetra, which is showing the number of ligands, amine, the name of the ligand, and the copper, which is the metal. Roman में 2 जो है, that is the oxidation number. And then after I left some gap over here, you can see that the gap, and then the counter ion as a sulfate, isn't it? Okay. Now let's move to next example. This is COEN whole thrice Cl3. So En is here a complex ligand. So what we are supposed to write? Instead of tri, we will write tris. Yes. So this will be tris, ethylene 1,2-diamine, ethylene diamine, or you can say ethane 1,2-diamine bhi bolte hain ise. Okay. So tris, ethylene diamine, cobalt, and find the oxidation number. It will be 3, and then chloride. We will not mention the number of the counter ion or number of the metal which will be written here. Yes, यहाँ जितने भी नंबर मेटल लिखे रहेंगे ना उनको देखेंगे हम, ना उनको मेंशन करेंगे नंबर, ना इनको नंबर मेंशन करेंगे. Yes. So you can see that tris, this is tris for 3, ethylene diamine for En, and then cobalt, and then oxidation number, and then I left some gap over here, and the Cl is chloride. didn't mention the number, and you are also not supposed to mention the number. Got it? You have not, you are like, you will not write. Yes. Another example. So think of it. Tell me what it will be. It will be like H2O is there, so aqua word use, and chlorine is there, so chlorido is there. So which will come first alphabetically? Aqua will come first. So we will write first. We will first mention aqua and then chlorido. So number of aqua is what? 5. So for this we will say penta, aqua, and then chlorine is chloro and chlorido. Both we can use. In some book you can see chlorido, in some book you can see chloro. So the both we can use. Chloro and then cobalt. What will be the oxidation number of this copper over here? Think of it. H2O is neutral, so 0, and Br is -1, Cl is -1, so copper will be +2, isn't it? So name will be penta aqua chloro copper 2 bromide. Clear? Now next example is here NiCO whole 4. That also we will do. आगे इसके further भी हम करेंगे इसका, but यहाँ पे देख लेते हैं. This CO is a neutral ligand. Yes, CO is neutral ligand, and the name is for CO is carbonyl. So what we will say? Tetracarbonyl nickel, and the oxidation number will be 0 because it is neutral ligand, isn't it? So like this. So this is the way to write the cationic complex. So now move to anionic complex. How to name an anionic complex? So for the anionic complex, obviously how to identify that it is an anionic complex. The first thing, it should have 2 metals, or it should start with the metal and then big paraffences will be there, and then or the big that complex compound must have negative charge. So there are the 3 ways by which we can identify that it is an anionic complex. So how to name it? There is a format for that. We will write first metal 1, whatever the metal is written before the paraffences, that we will write, and then we will add the number of ligands, and then name of ligands, and then in alphabetical order we will write, and then metal 2 we will write, and 8 metal 2 will end with the 8, and oxidation number should be in the Roman. So that's a start with this K4FeCN6. This is the most common coordination complex, and we are very well familiar with this. So how to name it? As I told you that metal 1, I didn't mention that you are supposed to mention the number of metal, isn't it? So whether it is 2, 3, 4, whatever, we will not write that, only the metal 1. So that is potassium. K is potassium, and the number of ligands for this 6. Hexa, name of ligand cyno or cynato. In some book you can get it cyno, in some book you can get cynato. So both are correct. Okay, cynato, and then for this Fe you will write metal के साथ 8 लगेगा, तो it is not ironate, we will not say. So इसका जो name होता है that is ferrous we will use. So ferrate here we will say. Yes, ferrate. And what is the oxidation number? This is +4, this is -6, so total Fe will have +2. So potassium hexacynato ferrate 2. I hope it is clear how to name. Another example is there Na3AlF6. And what is the common name for this? Can anybody tell me? Yes, you have done in isolation chapter. This is the formula of cryolite. Okay, so Na3AlF6, if it is, how to do that? Sodium is there, so we will forget about the number. Whatever the number is there, we don't have to mention this. So this is sodium, and then hexafluoro. In the fluoro or fluorido, both you can use. Okay, so hexafluoro, and this is aluminate. Aluminium will be aluminate over here. And what will be the oxidation number? Yes, very good, it is 3. So sodium hexafluoroaluminate 3. So this is the way how to name the anionic complex. Now how to name the compound which is having both cationic and anionic complex? No issue, we will add both the format. Like cationic complex का we will add counter ion को हटा देंगे, and anionic complex का we will add the first metal 1 हटा देंगे. That's it. Yes. So let's see this number of ligands here, name of ligands in alphabetical order, metal, oxidation number in Roman, and then यहाँ से हमने क्या कर दिया? Counter ion को gap कर दिया, isn't it? Will have some gap, and then यहाँ से हमने मेटल 1 को गायब कर दिया. So number of ligands, name of ligands, alphabetical order, metal 2, 8 and oxidation number as we saw. So this is the compound, and the one very interesting thing I just want to tell you here, that in this type of complex, the both metal, whatever the metal are there, they both have almost, like in most of the case, in 98%, 99% cases, both the metal will have the same oxidation number. Yes. So till now, you people have practiced a lot, and you know this, that if chromium copper always show +3 oxidation number in the complex compound. If whenever we talk about chromium and cobalt, it is always +3. Copper, it will +2. Iron can be +2, +3. Yes. So these are the basic observation which you could do, and you could have done this, and you have noticed this point. Okay. Chaliye, so let's see. So what we will write first, we will write this complex, and then we will write this complex. So this is number of ligands, that means 3, but it is bidentate. So we will write here tris. So tris ethylene diamine, this will be cobalt. And here it will be, what is this? Yes, hexachlorochromate. This will be chromate because metal 2 के साथ 8 लगाएंगे, isn't it? So hexachlorochromate, and then no counterand, but oxidation number should be 3 for both. So trisethylene diamine, cobalt 3, hexachlorochromate 3. Yes. Another example, if we do here also, copper and platinum are there, but the oxidation number should be same, almost like same hota hai yahan pe. So we can see that, we can find it like tetraamine copper, and here it will be tetracyanoplatinate, isn't it? Because it is in negative ligand. So it will end with the 8, platinate. And what will be the oxidation number? In both the case, it will be 2 oxidation number. I hope it is clear. Now, how to name a neutral complex? Neutral complex, that means they will have only one complex part, neither metal nor counterion, neither positive charge nor negative charge, kuch nahi hoga iske upar. Okay. So very few are there, like few ligands which are neutral, like carbonyl and nitrosyl. So they can be used for this compound. Same number of ligands, name of ligands in alphabetical order, and then metal only in oxidation number will be in the Roman in bracket. So like FeCO5. So what we'll say, this is 5, so penta, and this one is neutral ligand. So what we will say, carbonyl. Pentacarbonyl, iron 0, isn't it? Oxidation number is 0. And then next compound, if we talk about NiCO4, so what will be here it will be big bracket. I forgot to give. Yes. Okay. So what will be the name? This is tetracarbonyl nickel 0. Yes. So that's it about this today's class. And next class we will do about the Werner's concept. What is that? Primary valency and secondary valency. What is that coordination number and oxidation number? How they are different? Kaise karte? What is the relation between that? That we will do in the next video. So I hope whatever I have explained today, you got it. And okay, so watch the video properly. And we'll meet you in next class, next video. Till then, thank you, class.